AI is still in its early developmental stages, barely out of kindergarten, yet it's already reshaping corporate capital expenditure strategies, straining power grids, and redefining team dynamics. If the internet revolutionized the connection of information, AI is poised to connect judgments and decision-making at scale. In this episode, we'll explore its origins, the powerful engine it's building beneath the global economy, and the inevitable frictions that arise as it matures and expands. Chapter 1: Origins. From Rules to Generality. Let's embark on a brief historical journey. AI's roots trace back to rigid rule-based systems and basic statistical learning in the mid-20th century. The breakthrough came with deep learning in the 2010s, which thrived on massive scale, followed by the emergence of large language models that transformed specialized tools into versatile platforms. Three interlocking forces propelled this evolution: exploding volumes of data, exponential growth in computational power, and algorithmic refinements, each amplifying the others in a virtuous cycle. Two pivotal distribution shifts accelerated adoption: APIization, allowing developers to summon AI intelligence as easily as a web service, and cloud delivery, enabling businesses to rent sophisticated capabilities rather than invest in costly infrastructure. A core commercial insight emerges here: the heavy lifting of model training is a one-time expense, but inference, the ongoing querying and application, runs like a perpetual meter. Driving down per-query costs and latency is what separates intriguing prototypes from scalable, revenue-generating businesses. For instance, advancements in optimization techniques have reduced inference latencies from seconds to milliseconds in many applications, unlocking real-time use cases like conversational agents and instant analytics. Chapter 2: The Stack and the Money. Who's actually paying? Visualize the AI ecosystem as a three-tiered stack. At the bottom lies the hardware and power foundation: specialized accelerators like GPUs and NPUs, high-bandwidth memory, HBM, advanced optics for data transfer, liquid cooling systems to manage heat, and the electrical infrastructure including substations and transformers. The middle layer encompasses models and tools: foundational large models, vector databases for efficient retrieval, and agentic systems that autonomously invoke software or APIs. At the top are the practical use cases: automating document processing and code generation, enhancing customer operations, accelerating R&D, managing finance and risk, enabling industrial inspections, and deploying on-device copilots for personalized assistance. Now, let's talk dollars, the fuel powering this stack. US hyperscalers are unleashing unprecedented investments to dominate the AI landscape. Microsoft is on track to pour approximately $80 billion into AI-enabled data centers in fiscal year 2025, focusing on training and deployment infrastructure. Alphabet has ramped up its 2025 capital expenditure target to about $85 billion, with Q2 alone seeing $22.4 billion directed toward AI servers and cloud data centers, driven by surging demand. Amazon's AWS is accelerating toward an annualized capex pace exceeding $118 billion for 2025, per recent quarterly reports, as it builds out AI services amid fierce competition. This torrent of capital doesn't halt at the data center walls. It cascades into semiconductors, memory modules, optical networking, server racks, advanced cooling technologies, utility upgrades, and massive construction projects. Collectively, this AI industrial complex has become a macroeconomic force, with global private investment in generative AI alone reaching $33.9 billion in 2025, an 18.7% jump from the previous year. Overall, the AI market is valued at $391 billion as of 2025, projected to balloon to $1.81 trillion by 2030 at a compound annual growth rate of over 36%. These investments underscore a shift where AI infrastructure is no longer a niche expense but a foundational pillar of economic growth. Chapter 3: Productivity. How tech turns into profits. AI translates into bottom-line gains through three primary channels. First, task-level enhancements. Automating drafting, summarization, code reviews, and information retrieval, which can save hours in knowledge-intensive office roles. Studies indicate that workers using generative AI report saving about 5.4% of their weekly hours, equating to a roughly 1.1% productivity boost across broader applications. Second, workflow redesign. Minimizing handoffs, delays, and redundant checks by deploying one-stop agents that handle end-to-end processes, such as from query to resolution in customer service. Third, organizational redesign. Fostering AI-native teams that deconstruct jobs into modular tasks, with humans focusing on high-judgment exceptions and oversight. Early signals of impact are emerging in official metrics. U.S. non-farm business sector labor productivity rose 2.3% annually in 2024, accelerating to a revised 2.4% increase in Q2 2025. While not solely attributable to AI, this uptick aligns with widespread adoption. 78% of organizations reported using AI in 2024, up from 55% the prior year. A rule of thumb for leaders: true productivity equals technological capability multiplied by organizational absorption. Acquiring AI models is straightforward. Reshaping workflows and upskilling teams is the real challenge. For example, industries highly exposed to AI have seen revenue per employee grow 3 times faster than less exposed sectors, highlighting the tangible returns when integration is done right. Chapter 4: Distribution. Who benefits, who gets squeezed? As AI matures, profit pools are concentrating upstream in chips, foundational platforms, and cloud providers, while downstream gains accrue to specialized systems integrators in verticals like finance or manufacturing. Mid-tier generic software vendors face commoditization and pricing pressures unless they pivot to niche expertise or own critical workflows. Labor dynamics involve more task substitution than outright job elimination. High-skill professionals who master AI orchestration gain significant leverage, potentially boosting their output by up to 40% in certain roles, while routine-heavy positions experience greater displacement risks. Market structures defy simplistic open versus closed debates. Hybrids will prevail: open source for cost-sensitive, rapid iteration scenarios, and proprietary for domains demanding safety, intellectual property protection, or unmatched scale. Venture capital trends reflect this. AI-related deals captured 51% of total VC value in the first half of 2025, a stark rise from 12% in 2017, funneling billions toward innovative hybrids. Chapter 5: What AI actually solves. Beyond hype, AI delivers concrete, measurable gains across sectors. In healthcare, it streamlines triage, assists in medical imaging analysis, drafts clinical notes, and accelerates drug discovery screens, potentially reducing development timelines by 20% to 30%. Education benefits from adaptive tutoring systems that personalize learning, freeing teachers for deeper human interactions and improving student outcomes by up to 25% in targeted subjects. Industrial applications include predictive maintenance that cuts downtime by 15% to 20%, visual quality assurance for manufacturing defects, and optimized scheduling in supply chains to minimize costs. Public services leverage AI for handling high-volume inquiries, preparing case files, and summarizing regulations, enhancing efficiency in bureaucracies often bogged down by paperwork. The key to success? Start small. Pilot 5 targeted use cases, scale the 2 that demonstrate clear ROI, and let operational compound interest build. McKinsey estimates AI could unlock $4.4 trillion in annual productivity gains from corporate applications alone. Chapter 6: The Physical World Bottlenecks. As AI scales, 2 macro-level frictions loom large. First, surging power demand and grid constraints. Goldman Sachs projects global data center electricity consumption could surge by 165% by 2030 compared to 2023 levels, potentially accounting for 3% to 4% of worldwide power usage. This equates to hundreds of terawatt-hours annually, straining utilities and necessitating rapid expansions in renewable energy integration. Second, Hardware and interconnection bottlenecks. Transformer lead times in the US have ballooned from months pre-2020 to averages of 120 weeks by 2024, with some large unit orders extending to 5 years despite FERC's 2023 reforms aimed at clearing queue backlogs. Distribution transformers fare slightly better, averaging 30 weeks in Q2 2025, down from peaks over 100 weeks in 2023. In essence, when AI's compute hunger meets regulatory and supply chain hurdles, progress hinges on physical infrastructure, concrete pours, copper wiring, and policy timelines. Chapter 7: Social Contract. Inevitable and negotiable. AI's rise demands a recalibrated social contract. On inequality and retraining, the median worker thrives only through accessible upskilling, micro-credentials integrated into daily workflows, with 77% of C-suite executives confident in AI's productivity potential but emphasizing human-AI collaboration. Privacy, IP, and auditability issues persist. Debates rage over training data ownership and liability for model errors, spurring new insurance markets, rigorous red teaming, and enhanced evaluation frameworks. Concentration versus openness requires interoperability standards to prevent vendor lock-in, empowering small firms to innovate without rebuilding from scratch. Energy and environmental concerns. While AI adds near-term load, it can optimize grids and buildings for efficiency. The path forward pairs capacity growth with cleaner sources like solar and nuclear. Globally, 46% of employees in AI-restructured organizations express job security worries, underscoring the need for proactive policies. Chapter 8: 3 clocks, 3 scenarios. 3 timelines shape AI's trajectory. The short-term cycle, 12 to 18 months. Influenced by inflation, interest rates, and capex fluctuations, with big tech's combined $364 billion in planned 2025 investments setting the pace. Medium-term structure, 3 to 5 years, focused on grid expansions, permitting reforms, and enterprise absorption rates. Long-term geopolitics, 5 to 10 years. Encompassing mineral supply chains, energy security, data sovereignty, and international alliances. Possible futures. 1. Steady ascent. Gradual productivity climbs as inference costs drop and firms transition from pilots to full platforms. 2. Boom with bottlenecks. Massive capex surges, but power shortages and delays extend ROI timelines. 3. Regulatory fragmentation. Divergent global rules inflate costs and hinder diffusion, favoring agile localizers. Chapter 9: Investor Checklist. Arm yourself with this essential checklist. 1. Track hyperscaler capex execution. Microsoft's $80 billion FY 2025, Alphabet's $85 billion, and Amazon's $118 billion annualized as benchmarks, and verify supply chain deliveries. 2. Monitor unit inference cost and latency reductions via hardware-software synergies. 3. Gauge enterprise pilot to scale conversion, aiming for months-long timelines. 4. Watch grid indicators. Interconnection queue clearances, transformer lead times, still averaging 30 to 120 weeks, and utility investment plans. 5. Analyze BLS productivity versus unit labor costs in key sectors for efficiency signals. 6. Stay attuned to governance evolutions. Data portability, model evaluations, and liability frameworks to mitigate risks. AI isn't destined to automate everything away. It's designed to empower organizations to execute the right decisions consistently, even under duress. That's the alchemy turning tech waves into sustained economic growth. Stay curious, stay sharp.